Don't forget to like, subscribe and share the videos.
The topic that we are going to discuss now is radiative cooling paint. So what is this radiative cooling paint? Researchers at Jawaharlal Nehru Center for Advanced Scientific Research in Bengaluru, which is an autonomous institute of the Department of Science and Technology, have introduced an innovative paint that utilizes radiative cooling technology. So what is this radiative cooling technology? We need to understand, and what is the need for this technology? Let us understand that first. So in the wake of escalating global temperatures and the pressing need for substantial cooling solutions, there is this new innovation which is cost effective, eco-friendly technology. Okay, so this is an effective solution that we have at present. Let us understand what is radiative cooling technology and how does this work. First is, radiative cooling technology is a method which is designed to dissipate heat from any object by emitting thermal radiation. So this is important. So they are going to emit thermal radiation here, one, and it is going to be emitted into the atmosphere directly. Okay, next is, it will allow the object to become cooler. Obviously, when the thermal radiations are emitted, it will allow the object to become cooler. Next is, it leads to creation of cool surfaces by emitting thermal radiation. Yes, but it will emit directly into the extremely cold universe. This is important. Okay, they will not get dissipated into the hot environment of the atmosphere, but then they will be released into the extremely cold universe, that is around 3 Kelvin, very low temperatures. Okay, how is this happening? It is using atmospheric transmission window. What is this atmospheric transmission window? That is that part of the electromagnetic radiation where the transmission is very easy. Okay, it will transmit from the Earth's surface to the outer atmosphere very quickly. Okay, that range, that wavelength is 8 to 13 micrometers. Okay, next is, notably, this process occurs without any reliance on electricity, which is very important. So they are just going to use a paint coating. They are not going to involve any electricity. Thus, fossil fuel burning will also not be there. Thus, it becomes an eco-friendly solution. So this is how it happens. Incident solar radiation is causing the heat, and then there is heat from the surrounding. I mean, even the earth emits radiation, right? Even that is causing the heat. Okay, so these heat are emitted into the outer space. Okay, this is happening through that atmospheric transmission window. Okay, and then even the solar radiation is reflected back effectively. So reflection is there and transmission is also there. Okay, so this is how this cooling technology works. So what was the need? First is, there is global warming and urban heat island effects that are there, which have accentuated the necessity for effective cooling technologies. And then conventional active cooling devices like air conditioners, fans, refrigerators, which demand substantial electricity. Okay, and then it contributes to greenhouse gas emission and elevated surface temperature. So these conventional cooling devices that we have is heavily dependent on electricity. Okay, so it will in turn increase greenhouse gas emission and then it will elevate the surface temperature, whereas this radiative cooling technology addresses these challenges by emitting the thermal radiation without electricity consumption through the atmospheric transmission window that we discussed earlier. Okay, so this is what the technology is. And the new finding, what is that paint? What is it made of? So it is derived from a novel magnesium oxide polyvinylidene fluoride. Okay, PVDF, polyvinylidene fluoride, which is a polymer and nanocomposite, which has been prepared from materials which are earth abundant, cheap, non-toxic and non-harmful. So thus it becomes environment friendly and also it is economical. Next is, it showcases remarkable cooling capabilities with high solar reflectivity. This must be there. And then infrared thermal emissivity. Infrared is nothing but heat. Okay, heat radiations. Okay, so infrared thermal emissivity is also highest. So what are all the percentages here? So it resulted in high solar reflectance of 96.3%, huge. Again, exceptional thermal emission was also there, that is 98.5%. Okay, so that is why this technology is gaining popularity. Next is, with the outstanding optical features, it lowers the surface temperature by about 10 degrees Celsius in strong sunlight, outperforming the standard white paints that we have now. Moreover, it is water resistant and hydrophobic in nature. Hydrophobic means water resistant. Okay, so it guarantees effortless application on diverse surfaces, ensuring consistent coverage and strong adhesion. So these are all the things which we need to know about these radiative cooling